Now, before we continue toward that elusive final axiom for real numbers, I do want to take a small side trip to practice some techniques that are very useful in real analysis more generally. If there's one word that sort of goes along with real analysis, it's inequalities. And what I want to do now is show you some elementary techniques for determining and proving inequalities of real numbers. So we're going to do some algebraic manipulation to put inequalities in a convenient form, in particular so we can use things like our order axioms and other things. And then we can use the signs of the numbers to prove those inequalities. And then finally, we'll apply that strategy to a problem. So here's our example. So let a and b be real numbers, and suppose that a is less than 2 and b is greater than 3. And the question I want to ask is, which is bigger, a times b or 3a plus 2b minus 6? Now this may seem like kind of a random question to ask, and it kind of is, but it's looking at it in at least a superficial way, it's unclear why we could tell that either was bigger than the other. I mean, depending on the values of a and b, it's possible that ab can be bigger sometimes, or 3a plus 2b minus 6 could be bigger at other times. But if you put in a bunch of different numbers where, again, a is less than 2, b is greater than 3, you'll probably figure out that ab seems to be smaller than 3a plus 2b minus 6 all the time. May be surprising, but it appears to be true. So the question is, how could we prove this? Well, one way we can do is try to understand how the positive and negative numbers interact. And also see if we can make an equality that involves 0. Knowing whether something is positive or negative could be really helpful, right? So if we take this inequality that we want to prove and say subtract ab from both sides, we might say, well, let's see what happens with minus ab plus 3a plus 2b minus 6. Maybe proving that is greater than 0 is easier than proving the original inequality. So really, we want to know whether negative ab plus 3a plus 2b minus 6 is a positive number or a negative number. Well, one thing that can help us figure out whether a number is positive or negative is trying to factor it, right? So if we try to factor this, it looks like maybe we can group the first two things together, first two terms and the last two terms together, and then factor an a out of the first one and a 2 out of the second one. And then if we factor a negative out of that negative b plus 3, we get negative a times b minus 3. Then we can factor out a b minus 3, and we factored it into b minus 3 times negative a plus 2. And so if we know the sign of b minus 3 and the sign of negative a plus 2, we know how the multiplication works. We can figure out whether it's positive or negative. Well, we just so happen to know the signs of b minus 3 and negative a plus 2 because of the assumptions that we had on a and b. Remember that a was less than 2. That tells us that negative a plus 2, if we add negative a to both sides, is greater than 0. And since we know that b is greater than 3, if we subtract 3 from both sides, we get b minus 3 is greater than 0. Which means if we multiply the positive number b minus 3 times the positive number negative a plus 2, we're going to get a positive number. And now we can just sort of backtrack. B minus 3 times negative a plus 2, when we FOIL that out, is negative a b plus 3a plus 2b minus 6. And since b minus 3 times negative a plus 2 is greater than 0, that one is greater than 0 as well. And now we can add b to both sides of that inequality using translation invariance. And we get 3a plus 2b minus 6 is greater than ab. Flip that inequality around, and we get ab is less than 3a plus 2b minus 6, which gives us the very strange theorem. Let a, b be real numbers with a less than 2 and b greater than 3. Then a times b is less than 3a plus 2b minus 6. So now would be a good time for you to go to the in-class activities. You can do some more practice with inequalities, and all you have to do is click on the link below this video.